In the previous video, we studied what motion is. We also see one type of motion, that is rectilinear motion. Rectilinear motion is a straight line motion. In this type of motion, the path of the motion is a straight line. What will be if the path becomes circular? Yes, your guess is correct. If an object moving in a circular path, it is undergoing circular motion. More accurately, motion of an object along the circumference of a circle is the length of this boundary. It is curved. That is, when an object is moving along a circumference of a circle, we can say that it is undergoing circular motion. Can you give me a real life example in which an object executes a circular motion? Yes. What about satellite orbiting the earth? Yes, it is one of the circular motion. What is actually circular motion in definition? As how we are whirling that type of stone on a rope with our hands, we can see that circular motion. Yes. Notice the distance from your hand to that object is be always same in that case. What about a moving fan? It will be always undergoing circular motion. Yes. And when we tell about the points on the leaf, we can say that it is in a circular motion. But when we consider whole fan, is it in a circular motion? No, it is not going anywhere. The entire fan is not moving in a circumference of the circular motion. So what type of motion is going on here? It is rotational motion. Before going to that type of motion, let's understand about that. Here we can see that the road, this is angle. We can say that it is an axis. Yes, axis. The entire fan is spinning around the axis, or you can say that entire leaves are spinning around the fixed line. This type of motion is known as rotational motion. In words, motion of a body around a fixed line, and that fixed line is also known as axis of rotation. Some examples are rotation of wheel. How it becomes to rotate? Circular motion or rotational motion? Here we can see that leaves are in circular motion, but here comes we know that it is rotating on an axis. Then it becomes the rotational motion. Yes, and the same way as we studied that earth also rotating, or earth also rotating on along its axis. Yes, and here I told you that one example for the circular motion, when we are keeping one drop on our hand and rotating it. Okay, when we are rotating it, we know that there is one axle because we are keeping it on our hand, but the axle is not through that object, so it is circular motion. It is not rotational motion. When that rotational motion comes, yes, that movement is through that object is moving slowly through that loop or through that the line, then comes the rotational motion. Okay, circular motion, in circular motion there will be no axle. That means that object is outside the axle. Okay, when we are rotating that one, that axle is not moving and the object is not through that axle. So we studied that three types of motion today. It is circular motion, motion along the circumference of a circle, and motion along the fixed line and its pass through the body. It is known as axis of rotation, and that type of motion is known as rotational motion. Okay, motion along the fixed line. And next we have to check that how we will calculate the speed of an object. Here we can see that object 1 is more speed of 1 and object 2 is very slow. How we can guess that one is speedy one and another one is very slow? Yes, for calculate the speed, we have to consider two things. One is the distance covered by that object and the time in that. Okay, so distance and the time. Here we can take one example. Consider a car is moving. This movement we can say it is a rectilinear motion. Yes, and here for time for completing that move is 30 seconds. And here also we can consider another car, red car, it is moving, and the time taken for that one is 40 seconds. So how we will consider which one is more speed and which one is slower? Yes, here comes that equation for speed. For that we don't want not only want that time, we have to know the distance covered by these two cars. Here by this figure we know that the distance covered by both of them are same. So here we can say that it is 420 meter. The path length of both car is 420 meter. So how we can calculate the speed? That is red car, that speed is the unit as total distance by time. That means 420 meter by 40 second. It is 10.5. And for in the case of blue car, it is 420 meter by 30 second. That means 14 meter per second. Consider another car is moving in 20 seconds. So path length is same. So what will be its speed? Yes, here instead of that we can write as it is 21 meter per second. Yes, here we studied that 14 meter per second and 21 meter per second like that. Here comes the unit of the speed. Yes, it is termed as meter per second, m by s. And for longer distance we are saying it is kilometer per hour and feet per minute. And in very small one we will say that it is in miles per hour. Yes, and time taken, here we told that time taken is 30 seconds and the path length is 420 meter. By equation it is total distance by time. So we got it is 420 meter divided by 30 seconds. Here it is 14 meter per second. If speed is constant, can we say that it will move in every time in this 14 meter per second? No, it will not move like that. We know that when we are moving through a road itself, the speed of the car will change according to the crowd, according to the density of the vehicles. Yes, it will not be constant in the certain path. According to the path, there will be a change in the speed. Yes. So here we can calculate when an object is moving in a certain path, there will be a change in its speed. Okay, so then next portion is average speed. So that average speed we will study in our next class. So just to study the equation for speed and its unit and definition.